Let's do a couple of examples of Gauss-Jordan elimination. Let's start with a system of two equations and two unknowns. And the first thing we want to do to apply this approach is to write it in matrix form. So that's where we take the coefficients of x and put those in the first column, the coefficients of y in the second column, and the constants on the other side of the equal sign go in the third column. Once we've expressed it in matrix form, we're going to perform elimination steps, meaning multiplying rows by constants or subtracting multiples of rows from other rows. And we'll see at the end of this example why I'm making the choices I'm making here. But just to get through the first example, I'm going to tell you the choices as I make them. The first choice is to make this entry a 0. How can we do that? Well, we can subtract a multiple of the first row from it, and the right multiple to use to get things to cancel is 2. So I want to subtract 2 times the first row from the second row. So 2 times 1 is 2, and I subtract that from 2 to get 0. 2 times 3 is 6. If I subtract that from 1, I get negative 5. 2 times 5 is 10. If I subtract that from 0, I get negative 10. Okay. The next step is going to be to make this into a 1. And the easy way to do that is just to multiply the entire first equation by a number, or divide it in this case. In this case, we'll divide by negative 5. That would be the same as multiplying by negative 0.2. So, dividing row 2 by negative 5, remember you have to divide every entry by that value, every entry in the second row. The third step is going to be to make this a 0. So to make that a 0, I'm going to subtract 3 times the second row. So this should be a 3. So this times 3 is 3. 3 minus that is 0. This times 3 is 6. 5 minus 6 is negative 1. So that's where those values came from. Now, once we've done that, we can read the equations that are left. This first row represents the equation 1x plus 0y equals negative 1, which simplifies to just x equals negative 1. And the second row corresponds to the equation y equals negative 2. Or y equals positive 2. So we can see the answers in this right column here as long as we've arranged things so that the left side looks like an identity matrix. That's our goal, and that's how I decided on the goal at each step. I was trying to make things look like an identity matrix. So I already had a 1 where I want 1 in the top left corner. And then from there I just moved down the columns. I wanted a 0 everywhere below that. And once I got down to the bottom, then I moved back up the next column to make a 1 where I wanted it and a 0 where I wanted it. So let's see this strategy applied again, this time with a bigger system. Let's use a system of 3 equations with 3 unknowns. Again, we're going to express it in matrix form by taking the coefficients and writing them in columns. So this first column has just coefficients of x. The second column, coefficients of y. The third column, coefficients of z. And the last column are the values on the right sides of the equal signs. Now we're going to take steps to make the left side look like an identity matrix. So this matrix has 3 rows. If I take the first 3 rows and the first 3 columns, I'm going to try to make that look like an identity matrix. 1's on the diagonal, 0's everywhere else. Let's see what steps we could take. First, I'll subtract 2 times row 1 from row 2. That is to say, I'm doubling all those numbers before I subtract them. So 2 minus 2 gives me 0. 3 minus 2 gives me 1. 3 minus 2 gives me 1. 11 minus 8 gives me 3. Now I have a 0 here. Next I'm going to make a 0 there. I can do that if we subtract 4 times the first row from the third row. Notice how things in this example worked out very nicely for us. I already have a 0 here, which would have been the next goal, and a 1 here. So I can move on to making this into a 1. Let's do that. So the next thing I'll do is divide the bottom row by -5. And looking at this, we can see we're well on our way to making it look like an identity matrix. All that I have to do next is to make all these things into zeros. So let's start with the piece right here. We'll make that into a 0 by subtracting the 1 that's below it. So we'll subtract, I misspoke. I wanted to work on this entry next. I want to make that into a 0. So we'll do that by subtracting the 1 that's below it. And we have to go across the whole row. So it's this 0 minus this 0 gives us this 0. This 1 minus this 0 gives us this 1. This 1 minus this 1 gives us this 0. This 3 minus this 3 gives us this 0. Okay, next I'm going to make this into a 0. I can do that if we subtract 1 times row 2 from row 1. So I'm subtracting this whole row from this whole row, and you can verify that the result is this new row 1. And then I've got one more step to work on. I want to make this into a 0. To do that, I can subtract this number that's below it. So I can subtract 1 times row 3. At this point, everything here on the left side looks like an identity matrix. And from that, I'm going to be able to read off the values now from the final column. The first row gives me the x value, the second row the y value, and the third row the z value.